Greetings and salutations. We're back. As I speak to the future, you listen to the past in your present. Okay, so the last installment, we talked about making chemical manufacturing plants or a chemical plant. What were the things that you needed to do and not do, and all that other wonderful stuff. We also talked about waste disposal and all that. Today, this part, we're looking at safety, chemical safety. And this is going to be a two-part, okay? And you'll see. So the thing is, the student will describe OSHA and its goal to keep workers and community members safe from exposure to hazardous chemicals. Yep, and we're going to be starting ourselves on good old slide 36 for this one. Ooh, and boom. Protection. Really an important thing, ladies and gentlemen. They need to know, all people would need to know how the safe use of chemicals, tools, equipment, things like that. What do you do when mercury spills on the floor? You can't sweep it up with a broom and a dustpan. You can't wipe it up with a paper towel. That's not going to work. In this case, if you have a lot of mercury on the floor, you need a special mercury vacuum to suck it up. Don't touch it with your bare hands. Those are the important things as far as knowing what to do when mercury has been spilled. Okay? So it's important to know and be trained on safe use of chemicals, tools, and equipment. There is a federal government organization called the Occupational Safety and Health Administration, known as OSHA. And the idea is that they ensure safe, healthful conditions for workers on an occupational level, safety level, health level, and administrative level. As you can see down below, every workplace has OSHA regulations posted on there. It is required by law. Yes, even at Western, we do have that. Okay? So, that is the real world. So, what about protection? Well, the right to understand laws ensure workers know what the chemicals they are exposed to and what are the health effects. Why would you want to wear the personal protective equipment? PPE. That is an actual abbreviation that is used. Okay? So, what are the things that help us out? Well, there's something called safety data sheets, SDS, and training. There is also the material data safety. Let's try that again. The material data safety sheets, MSDS. And you're going to have an assignment for the MSDS. Okay? Now, that being said, we're going to talk about the MSDS a little bit here, but a whole lot in another video. So safety data sheets would include things like product and company identification. It talks about, in this case here, this is dealing with Elmer's glue. Yeah, the stuff you get to play with when you were a little kid. You did the arts and crafts and you glued the construction paper and all that other stuff. You remember those days. I bet you do. And some of you wish you could go back to it. Guess what? You can't. Now, there's also the material safety data sheet. And there again, this is a different version of it. There's a different, they do come in different forms. So, like section one, product identification, there's several sections, okay, to deal with that. And it talks about the name of the product, what is the product used for, what kind of class is it, what is the Department of Transportation classification? Well, it's not regulated. Well, what do you mean? Well, it's not something that if it was spilled on the highway that you have to call a hazardous materials team and they have to be extra, extra careful in how to handle and cleaning up the mess. Okay. To give you guys an idea, one year I ordered gas canisters for portable burners. Okay. Because we did not have the gas system going at the time at the school. And I paid, I don't remember how much I paid for the gas canisters. The normal, these were butane gas canisters. And it turned out I paid more for the hazardous materials shipping fee than I did for the actual gas canisters. Can you believe it? But that's the way it is. Okay. So again, here you can look here. It gives you the manufacturer. It gives you the address. It gives you the telephone and the emergency phone if something goes down and it's not pretty. Okay. Oops. All right. How about laboratory equipment? Well, you had chemistry. All you guys have had chemistry. Wearing gloves, goggles, a respirator when required, wearing the appropriate clothing like an apron, return equipment to the proper location, retract electrical cords so the goof after you doesn't trip and does a face plant into a pool of acid. Yeah, things like that. Handling items carefully, making sure the equipment works correctly within the acceptable parameters. Okay? So you don't pour your favorite energy drink in a flask that's got hydrochloric acid in it. Things like that. Of course, cleaning items after use, that would be good. There is no such thing as the dishwasher in a chemical lab. It is a human technician who becomes the dishwasher. Okay? They don't use regular soap, they use certain kinds of soap on there, certain kinds of detergent, but it's not the kind that you would have in a dishwasher. It's not the kind that you would have in the kitchen because I don't have that in the lab myself. Of course, asking for handling demonstrations, that would be good as well. Well, I'm going to move away from the chemical safety. I will revisit it in another video with you guys. But I figure I'm going to go ahead and finish off the video, finish off our chapter here. We only have a few slides left. Okay, all right, you apes fans, here you go. What about going green from a chemical perspective? What about this going green thing? So this is where we got to talk about bioplastics. Ooh, bioplastics, what's that? Think plastic materials produced from renewable biomass structures such as vegetable fats and oils, cornstarch, straw, wood chips, sawdust, recycled food waste, etc. Sounds delicious. Bioplastic can be made from agricultural byproducts and also from used plastic bottles and other containers using microorganisms. You'd say, wait, used plastic bottles? Right. Where does plastic come from in the first place? Plastic tree? Guess again. Oh, I know. The stork. You're hopeless. Seriously, you're hopeless. All right. Seriously, plastic comes from oil. Okay. And where does oil come from? I know. I got that, teacher. Yeah, pick on me. Yeah. What is it, Patrick? It comes from the ground. Bravo, Patrick. Yes, we find it in the ground, but where does the oil come from? Some people would say, oh, it's the dinosaurs. Uh, Not the entire story. It's mostly dead plant material that has been under the ground for a long time. That is what's the basic components of oil. Okay? So, now we got an idea where plastic comes from. It makes sense that it would be biodegradable. Okay? So, bioplastics, in fact, are biodegradable. Now, the thing is, it's not that they get recycled, but they have to be composted. What's composting mean? Well, you'll have an area and you're going to be putting on these bioplastic waste products in there. And what happens is the bacteria that's naturally there, they will start to break it down. They look upon the bioplastics as food And with the bacteria eating these bioplastics, biodegrading them, okay, they end up getting food, they get energy, and then they have the ability to reproduce, because in order to reproduce, you have to have the energy. That's how it works. Okay? So, how can we have a practical use here? And again, chemical engineering comes into play here. Apes, we talked a little bit about this. The garbage patch in the Pacific Ocean is made up mostly of plastic. There are two places in the Pacific Ocean. Hey, in case you're wondering where we are on the map, we're right about here. We got one giant, this is the eastern garbage patch, or the North Pacific subtropical high. Over here is the west garbage patch. Okay, and this is the subtropical convergence zone. Okay, so literally, it's just a trash accumulation. A gyre that's created trash accumulation. It's a large system. A gyre is a large system of circulating ocean currents. So it makes sense if they're circling around like this and plastic's floating around in the sea, it would go and join up. Okay? So what does that look like? Well, here it is looking at it from an underwater view. I mean, you got trash from God only knows where, all over the world, from the Americas, from Asia, from Australia, okay, and it piles up. And this is what it looks like on the surface. It looks wrong. It looks disgusting, okay? This is not being a good steward of God's earth. That's really the sad part, okay? So this is also looking at the going green, the Great Pacific Garbage Patch. Okay, think about this. 46% of the total mass is made of discarded fishing gear. Yeah. So when you look at it, here are the statistics, okay, on this. And this is like a massive pile of trash, like you saw here. This is it. This is just not yummy, okay? So I want to point something out before I go to the last slide. There are scientists who are working on bacteria that would actually break down plastic, and that's really cool. And there are people who are eager to try it out, and oh, that's going to be our solution. But here comes the thing. We don't know what the long-term effects are of using these bacteria to break down this garbage. We may end up with something far worse than what we're starting out to begin with. Okay? So, just some things to think about on that one. Let's conclude the chapter, guys. So, chemical engineering in action. How about clean coal? Coal is something connected usually with dirty. It's when you burn it, it's creating the smoke, it's creating ash and soot and all that. But clean coal, how about techniques that trap harmful gases like carbon dioxide and other toxins? And there's coal gasification. So, in other words, you're taking coal and you're able to change it to a gas, from a solid to a gas. And the thing is about that, it sequesters, it contains, it envelopes, it surrounds carbon dioxide, which certainly is considered a greenhouse gas. Okay? All right, ladies and gentlemen. So this is actually the end of chemical engineering, but not the end of the videos, because I do have one or two more videos to show you guys about chemical engineering in the real world. So let's wrap up. So we talked a little bit about coal gasification, clean coal. We talked about the garbage patch that we have in the Pacific Ocean as a result of plastic pollution. We talked about the idea of going green from a chemical engineering perspective, looking at bioplastics. What can we do with bioplastics? We talked a little bit about lab equipment, how to handle it, what to do, what not to do. We looked at material safety data sheet, which I'm going to devote an entire video on that, because there'll be a project for it, safety data sheets. We talked about the idea of protection, okay, looking at OSHA, who's on the lookout for you. I'm Trev Lucas Spa Woo, and I'm signing off. Laters.